movement is this. Yeah, because what I want to do is take stuff that you guys know how to do. I want to take 1, 2, 3-step equations, and I want to walk through how we set up and solve them, but I want to do it in such a way that I will not skip steps. Okay? The reason why I don't want to skip things and skip steps is because as we get into the actual geometry proofs, which we'll probably get to on Thursday, you have to be very specific as to what you're going to do. For example, if I look at this equation, what's the very first thing you're going to do? From where? From one side, which means you have to do it to the other. So when you do things to both sides, you're keeping it what? You're keeping it equal. Very good. So you are subtracting the same thing from both sides, keeping it equal. After you do that, what do you do next? You're getting ahead of yourself. You're not solving. You're basically when you're solving it, it means you're done. You have your answer. Very good. I'm simplifying where I'm at. Okay? I'm rewriting. Okay. So I get 2x then equals what? All right. So then I just simplified my step. Now what do I do? Are you keeping it equal? Because you're doing it to what? Both sides. What do you do now? It's solved. What's your answer? Okay. So in essence, by writing all of that out, not what's on that green piece of paper. Yeah, put it away. By writing all this out, by putting it into what I'm going to call a 2-column proof. What we did on the side that did all the math is we wrote down what are called statements. These statements were written down for a specific reason. So this is what we call a 2-column proof. The column on one side, the left side, will be all of your statements, what you're doing. The column on the right are the reasons why you're doing it. Okay. That's what happens. So this is where we get into the proof stuff, which most of you guys heard of, the best part of everything. Okay. What do you think the reason was that I wrote down 2x plus 3 equals 7? To find x. Did I basically just give you something to do? 99.9% of the time, the first thing you always write down is what we call your given information. We gave you a problem to do. Gave you 2x plus 3 equals 7. Later, in later days, in a couple of days, we might say something like this. Your given information could be x is the midpoint of zy. Which means, what's the first thing you would write down? X is the midpoint of zy. Okay. What does the midpoint do? It bisects. It creates how many congruent segments? Okay. So what happens here is that we're developing the idea that a given statement, whether it's a geometry term or an algebraic equation, has something that can happen to it next. What was the next thing we did? We subtract 3. So when you subtract something from both sides of the equation, that actually is a property. So let me give you guys. Yes, it's called the subtraction property of equality. This handy-dandy reason bank property sheet is going to be your best friend. This reason bank thingy is going to have all the information for this first chapter or so, as far as things that you are going to be allowed to put on your reasoning page. Okay? We have a statement side and your reason side. Today, we're only going to be looking at 4 properties. Okay, today we're only going to be looking at 4 properties. As we get going into this, we'll be looking at more and more and more of these. Thank you. So, what I want to do before we get too far into this is kind of remind you guys of abbreviations. I'm going to allow you guys to abbreviate instead of writing out addition property of equality. I'm going to write it out in legal formats of abbreviations. Okay? Don't complain, or you'll have to write it out. Sorry. Addition property of equality. Basically, that means you're adding the same thing to both sides. Okay? Subtraction property of equality. You're subtracting both things from opposite sides. Division or multiplication, you're multiplying both sides. Division, you're dividing both sides. You're keeping it equal throughout. Okay? Whenever you do that algebraically, you're using one of these properties. Well, let's abbreviate it. Write this off to the side. Add, prop, equal. That means it's going to be that is a legal way to abbreviate. Put away the green sheet for the second time. Thank you. Do your other stuff some other point in time. Okay? Excuse me. Subtraction property. When we do the same thing to both sides when we're subtracting, we're only going to use subtract. S-U-B-T. The reason why I put that T in there is because substitution looks a lot like it. We'll talk about that tomorrow. Okay. Multiplication, mult. And then the only one that I use a symbol for is division, because it looks like it's only symbol. Okay. It's the only one I'll use a symbol for. I use that little division symbol. When I ask you guys, please, I should have hole punched this. I'm sorry, some of you guys have three little ring binders. I have a hole punch back here. I'll pass it around if you want to hole punch it, but don't lose this. You're going to be allowed to use this on quizzes and stuff. There's a lot more other things that we will start to develop. For example, like something like this, if you have a midpoint, we're going to develop what I call progressions. We're going to put it in a box. We're going to create our own little graphic organizer type thingy that'll have a whole bunch of, if you're given a midpoint, if you're given a bisector, if you're given an angle bisector, if you're given a right angle, all these different things on how to start a proof. All your how-tos will be right here, and then it's just a matter of piecing it back together. Okay? So going back to what we just wrote out, that first example, what property did I use for that minus 3? Yeah. So we write subtraction property equal. When I rewrote that, we said it a second ago, we did what? We simplified. Whenever you rewrite something, we're just going to call it simplify. What did you do after that? Yeah, exactly. And then when you are done, you have therefore solved. Yep. You're solved. It's a graphic way of putting together a kind of like how you were able to solve an algebraic equation by using properties and definitions. And that's kind of what we start to get at the further we go with the proof stuff. Is that we're going to use the same basic scenario of reasons are always properties, definitions, theorems. Statements are what you're doing. That reason bank is your why. Let's try another one. I've written out the word statements once, and I've written out the word reasons once. I'm done writing out statements and reasons. I can't hear you. I can't hear you. What do you want? Oh, the door. I'm busy. Yeah, always that. So I'm busy. Whatever. What's your reason for writing it down? Sorry, I had whiskey last year, and he just continually tries to annoy me after this year, so I apologize. What do you do next? You know how to solve these equations. That's not hard. Yeah, so you just write it out. What this is doing, in essence, it's training your brain to slow down. Okay, it's training your brain to slow down and think about why did you write something down? What was the reason you wrote it? Then what? Yeah, you simplify. Very good, very good. And then what? You divide both sides by 5. Good, so you write it out as your... And x equals... These are technically proofs, guys. These are proofs. These are the things that people hate. And as you can see, they're not terrible. Okay. Well, yeah, obviously there's a yet to it, but it's the idea that you get comfortable with the idea you get comfortable with the idea of writing it out. It's not like I'm trying to show you guys how to prove. And this is the reason why you say it here. It's not scare the what's out of your children. Yeah, just here. Just try to see if you can read into that. These are college groups. That's like, good luck. Here. And seriously, if you're passing through around, it's nutty. It's crazy. No, there's like 3 of them there. What do you do first? What's your first reason for the first problem? Yes, ma'am. Given. Very good. What did you do first? I mean, now what do you do? Add prop. Equal. You add 8 to both sides, so you're using the add prob equal. And then what I heard? Simplify. Very good. Was that 42? Yeah. Divided by 14. And it is very good. All right. Not too scary, is it? All right. The other one, I'm guessing you did given, subtraction property equality, simplified, bless you, division property equal, solve. Now, remember, a lot of times when you're writing this stuff out, most of you can probably solve these equations in 2 steps and be done without having to write all those simplifieds out. And that's okay. But what happens in geometry, we start doing these column stuff. You have to be extremely literal as to what you're writing down and your rationale behind it. Because if you skip any of this, it becomes an invalid argument. Okay? All of these are logical arguments as far as how to get to a solution. That's what we're getting. Let's try one that has a different property. What's that? 7/8 x minus 4 equals 10. Careful. When you're solving equations, remember when you're solving equations, you're always working backwards off of. Correct. So when you're solving, you work that way. Yes, this adds up. So what do you have to undo first? Yes, ma'am. Where at? The minus 4? Because it was 7. Again, trying to be a clock. Whoever's doing it, stop. That's x, that's a minus. What's your first reason for writing it down? Get it. Okay. What are you undoing first? Working backwards. We're undoing the subtractions. We have to do what? Yep. Add 4 to both sides. So that is called D. Good. All right. Now what? Now what are you going to do? Multiply by what? 8, good. Now, when you're multiplying by 8, sometimes it's kind of weird to write it out. I'd usually write it as times 8 here, times 8 here. Because I know that if I multiply it by 8, that's going to, the fractional 8 part will go away. But what property is that? Property equal, good. So 7/8 times 8 is 7. So we have 7x equals, what is it, 112? I believe. All right. What was my reason for writing that down? Good. And then lastly, what do we, oh, I'm sorry, we have 2 steps left, unfortunately. Yep. And your answer is? And your reason? Now, what you were saying earlier, multiply by 8. Because that's what you do. It just get kind of messy. There's nothing wrong with it. That's where you're going to multiply. Actually, you have to distribute her. 7x minus 3. You would have gotten the same result. This is the result. That's why I was like, you can, but Sure. What's that? Yeah, you can go that way too. The reason why I write it out this way is because I'm working backwards. Off of this, I hit division before I hit multiplication. It's just a cleaner way to write it. You can write divide by 7 on both sides and then multiply by 8. You get the same thing, but you got to be careful on how you rewrite it because a lot of times when people divide by 7, they forget what they're doing. Okay, it's very easy to mess up something like that. That's why I try to stick with just working backwards. You're less likely to screw up a fraction. But like I was saying though, there are many other ways of writing and solving equations. As you guys all know, there are shortcuts here and there. It's completely valid to use those shortcuts. You know, for example, she was saying that you can multiply everything by 8 to get rid of the fraction. Yes, but the reason that you'd be behind doing all that is we'd be distributive property and working your way out of that. There are many, many different things. We'll talk about distributive property and how that works within a proof and how you rewrite things. We'll do that tomorrow. Today, I just want to work with just simple, as easy as possible. But if you come up with another way of doing it, you're not wrong. You know, like you said, you could have divided before you multiplied it. It's not a big deal. But if we try to stick with this generic idea, sometimes it's easier on our brains. Okay? Also, a lot of times you guys will see textbooks and stuff like that. They number their statements. They number their reasons. I honestly don't find it if we do or if we don't, it's not a big deal. What I would like you guys to do, is for every statement or every reason, just try to use just one line. That way you keep them together. That way you're not making something longer and shortcutting it, going back in the other way. It's super easy to get lost in what's not right. That's a trick. So you remember that. Oh, there's a left negative infinity. Do you remember that? Yeah. Yeah. So the function for all domain that's real, be a function that let x sub 0 be an accumulation point of delta, such that x is an element of delta and x sub 0 is greater than x, we say the limit of x as approaches x sub 0 is negative infinity. For every something subset of the real, there is a theta greater than 0 such that f of x is less than n. Whatever x is, I have no idea what it means. We have a Google app and they can just take a picture of that and Google Translate it. Yeah, this is the only thing. Yeah. Yes, sir. It's 45 degrees, right? 2 over 2. Pi over 4. I keep that because I go, no, I took it to class. Pretty sure I passed it. I got a job. I must have done something right. And that's the thing. And we sat in there half the time going, wait, why am I here? Yes, ma'am. We're still getting to the logical arguments. So arguments, a lot of this is building in the idea of how logic works. We're getting there. We'll be fine. I'm done. It's good to meet you. There you go. Now, see how you took on steps? You have to just space it out. So you know what you're doing. Yeah. Just space it out so that way for every line that you're doing something, you stay on the same line. You know you don't get things mixed up. Yeah, you're doing it right. So let's see. With any luck, most of you guys did this right away. Times 14 times 14. You guys did that right away. Multiplication property equality, multiply 14 to both sides. I hope. You simplified it and you got 224.
Yeah.
After that, what did we do? We added 12 to both sides. We did an add, prop, equal. And then it was solved. Was it QED, quantum, enum, dunum? QED, I think it's QED is for solved. It's for which can't be QED. It's Latin for something that which can't be disproved. What's that? No, it's my math, right? 236. Okay. So here's what we got. We got about 7 of these for you this evening. Because we need some time now. What I'd like. Alright, so what I would like you to do, use this paper kind of as your book. That way. I want you guys to do numbers 3, then 9 through 14. Obviously, you have to do it on a separate sheet of paper. But I want you to do all the statements of reasons. So you're just going to make the little T-chart, do the whole proof thing. And the only reasons and stuff that you guys really know how to use right now are those first 4, as well as simplify and solve. So there's really only 6 things, sorry, 7 if you're okay? The 156 side. Okay. So can I steal your notebook for a second, please? So just like we were doing in class, guys, see how she had her stuff with the little proofs and the thingies and the givens and the stuff? That's exactly what it should look like. It should be more than a sheet of paper, really. The algebra is not difficult, and I tried never to give you guys any of the tough algebra stuff to start out with this, because the algebra shouldn't be the deterrent to figuring this out. It's the idea that you get the string of thoughts correctly. Okay. So we'll go through this tomorrow. We'll throw in some distributive property tomorrow. We'll throw in some other crazy simplifying ways we can do, and then we'll start with the angles and or segments then on Thursday, but we'll have to add to our list stuff. Okay? It's not bad. It really isn't. No, not this week. I'm pretty confident. I highly, 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 highly doubt it. Okay? Do not foresee it happening at this moment.